Alright, I'm going to call this video Early Math Lesson 14. I have not been able to work with my grandson in a consistent manner. Did work with him a couple of days ago, and I'm still on Lesson 13 because it's been a month and we've only seen each other maybe 3 times. And I got what I thought I'd get. I forgot how to do that. Oh, no big surprise there. If you're not working consistently with the material, then it's not going to become working knowledge. He still had some benefits, no question about that. We're in a different place than when we started. But could we be making a whole lot more progress if we were working on a daily basis? Absolutely. All right, so I'm just going to do the first 12 problems and talk about those in terms of how he did with those. And then I think I'll do the next 2 pages of work, which is basically a rehash, mostly a rehash of the first 12 problems. So the first problem was 1/4 equals what over 20, which is really the inverse of reducing a fraction. And I wanted him to really start to look at the common denominator if something's divided by 4 and something divided by 6, because he definitely knows how to do bingo, bango, bongo, the shortcut to if they don't have any common factors, those denominators, no common factors, bingo, bango, bongo, he can do on the spot very quickly and easily. That's a plus. All right, so I think he was able to get n equals 5, and my work with him was to say, well, how do you get from 4 to 20? You multiply by 5, and if you change that, 1/4 does not equal 1 over 20, but it does equal 5 over 20. And he sees that. So he started seeing that. So was he able to do 5/3 equals n over 21? Yes. Yes, he multiplied by 7, and he wrote 35. Okay, so a little bit of practice got him that. All right, problems 3 and 4 were asking the question, what's the least common denominator? So I'm throwing some terminology at him. And he said, well, what do you mean by that? And I said, well, what's the smallest number 4 and 6 both go into? He initially said 24. And I said, no, something smaller. And he eventually, I think, said 12. And so this problem here, what did I want him to do? I wanted him to multiply how to get to 12. This is 3, that is 3, and this is 2, and that is 2. So that was part of what we talked about. I think I probably wrote before we did that. Let's do it over here. All right, so 1/4 plus 5, 6. I probably, because we have whiteboards, little tablets. That's 1 over 2 times 2, and this is 5 over 2 times 3. Well, what's this one need? This is common. What's not common to this one? That 2. What's not common to this one? That 3. So what's new? 2 over 2, 3 over 3, and so we looked at it from that perspective as well, just getting the conversation started. And so then I said, okay, bingo, bango, bongo, we could still do it. 1 times 6 is 6, and 4 times 5 is 20 over 24. So we got 26 over 24. Whoops, I probably did that. What do they have in common? 13 over 12. Okay, so 12 becomes how? A 3 and a 3. A 12 becomes how? A 2 and a 2. And it looks like I got 3 and 10, 13 over 12. Might have taken a little more time, but that's what we did. All right, so that was enough practice to here. All right, we continued on. 7.8 times 1,000, you remember that. When we started, he didn't know how to do that. Now he wrote very quickly, 3 zeros, and so he moved the decimal place. It was here. He put some zeros down, and he moved it 3 places. That was good. And then I probably said to him, is there another way of writing 1,000? How about times 10 to the 3? How many zeros does that have? So we had that discussion too. All right, so that's number 7. Number 8, I basically told him, multiply 6 times 15. He did. I think he probably did it this way, right? And then I corrected him and I said, can't you do that in your head? Can't you do 6 times 10 plus 5? Because we've been working on that. And he saw that as 90. Okay. And then we talked about the decimals. Well, isn't this really 15 over 100? Isn't this really times 6 over 10? And so what's your common denominator going to, well, no, I didn't say common denominator, but what do you do when you multiply? Bottom times bottom, top times top. Okay, how many decimal places would you move this if you're dividing by 1,000? So a familiar theme here. Just getting the conversation started. We're going to have it again. He hasn't done these problems yet. He did lesson set 13. He hasn't done these. All right, this is what I'm expecting to see some progress on this. And so we looked at it originally and we said, well, how many decimal places from the right-hand digit to the left? Looks like 2. How many over here? 1. And 2 and 1 makes, move the decimal how many places? 3. So I'm just, I'm a high school teacher. I'm not a young elementary school teacher. So my understanding of this is going to improve as I keep doing it. And hopefully the explanations will as well. But that's where I'm at right now. All right. And so then repetition time. 394 over 1,000. It was a different number on what we did, first 12 problems we worked on. And I'm hoping that he writes 0.394. Divided by 100. I hope he puts a 0 in front and moves it 2 decimal places. 11/8. What is it as a decimal? And he has been putting 11 into 8 rather than 8 into 11. He's been doing that pretty, and I heard from folks that, yeah, he occasionally switches letters. So, little concern there, but we'll see. I gave him a little bit of a, how long are you going to do that for? How long will it take you to put 8 into 11? And I hope I wasn't too harsh when I said that. But let's see what he does with a little push. And if he still puts 11 into 8, then I'm not going to push. Just going to work with what I see. All right. And so we've been working with, where's the decimal? Boom. And once you put it there, what do? Boom. Okay. And then you start adding your zeros until you don't need to work with them anymore. 8 goes into 11. He was originally putting the number above this digit. I'm forcing it to go above that one. All right. It fits in 1 and a little more. Okay, so we continue to have those conversations. Hoping he says that. Hoping he brings it down. I don't care if he puts the decimal there or not. 8 goes into 30. We're working those times tables. He's going to get to 3 eventually. To 24, and then we got ourselves a 6 and a 0. Looks like we got to do it again with those times tables. 56, and then we got a 4, and we got to bring another one down, and we're going to work through that. And then I gave him another one right on the spot, which is easier in terms of decimal and remainder. 2351 divided by 5. We're going to do the same thing. 2351 divided by 5. Write it as a decimal. Then I come back to 3 halves equals 30 over what? Last time the what was in the numerator, now it's in the denominator. And I hope he sees times 10. So times 10, 30 over 20. That's what I hope he sees. All right, back side. Now, he was done at problem 12 after school. He was getting glassy-eyed. He needed a snack, he needed to eat something, he needed to play. All right? But what we're doing is really important. So, working with him again tomorrow. This is all going to happen tomorrow. And I'll report back where we're at, make another worksheet because we're working again on Sunday. Okay, so hopefully some more consistency. 5.32 times 10 to the 2. I'm hoping he's seeing that as 100. I know he understands what an exponent is now, and he's going to move it 2 decimal places. We'll find out. 10 to the negative 2. Might have to rewrite that as 1 over 100. Do the commutative property multiplication. Hopefully he moves it 2 decimal places to the left. I'm hoping right? You can see the repetition now. So multiplying by 5, numerator and denominator. Multiplying by 3, numerator and denominator. Nope, no common factors. So bingo, bango, bongo. 33 and 20, 53 over 44. Boom, done. I think you'll do that quickly. I could have done it. Maybe I'll do it as subtraction. Since we already did an addition, I know we can do that equally as well. But when he first started, he did 4 times 5 first. So I'll probably change that to subtraction on the fly. 0.21 times 2, I hope he multiplies 21 times 2, and then moves the decimal 2 places. 9 times 7, I was hitting him hard with 9 multiples of 9 3 weeks ago. I want to see if he remembers that on the spot instead of 63, and if he doesn't say it immediately, I'm going to tell him the same thing I've been telling him for 2-3 months. Got to learn your times tables better. 34 times 10 to the negative 2. Again, repetition coming in when he has a chance to get away from it for 10 or 15 minutes. I'm coming back to it. All right, so hopefully he moves that 2 decimal places to the left. Then I'm giving him 7/5 times 50. We have talked about that, but not recently. I'm hoping he divides, I hope he does it by dividing 5 into 50 times 7, 70. But if he does 350 divided by 5, I'll make him do the long division, make it painful. You know, I'll tell him to reduce it, make it painful, and then hopefully show him. Could have done it. And then I'm hoping he shows the 5 into the 50. If not, I'll have him do 35 over 50 and reduce it. And then show him the shortcut. Give him one more. Hopefully he divides 4 into 16. I think he will, because once he sees the pattern before. So it just gives him one more repetition, smooth out that neuronal pathway. 29%, I'll ask him to write it as a decimal. I hope he sees 29 over 100, then moves the decimal 2 places. Going to do the same thing with 99%. Going to do the same thing with 350%. And then we're going to talk again, how do you get the decimal? 7/5 is what is a decimal? He's had a chance to forget the long division. We're going right back to it. He did know what log 2 of 8 was 2 months ago. I asked him when we worked 2 days ago, I forget, a couple of days back. And he forgot, and then he remembered. And so then I'll see if he can do log base 10 of 1 over 100, really push that brain, if he's not too glassy-eyed. But Friday, no school. I'm expecting we can do all of these. 5 times 10 to the negative 3, a little repetition. And then I'm showing him the difference between 2 plus 5 over 5 times 9 and 2 times 5 over 5 times 9. Going to push a little concept there. What's the inverse of division? Multiplication. What's the numerator? Multiplication. Then you can do some inverse operations and cancel the 5s. What's the inverse of multiplication? Division. Do we have division or multiplication in the numerator? No. So I want him to write this as 2 over 45 plus 5 over 45. And we'll have him do it out first to get 7 over 45 and show me how that works. That's the conversation we're going to have, that we need to have. Will we get there? Iffy. We'll see how he progresses. Okay? Will we get there the second time we do it? When we repeat this and I change the numbers? Absolutely. I have confidence. We worked a couple of days ago. We're working again tomorrow. And if all goes well, again on Sunday. Okay. So, just a few more problems. 3% of 5 I'll do for him. I just want him to follow. 7/2 times 6 over 35, I'll give him a choice to either follow or do it himself. I want to see 7 into 35. I want to see 2 into 6. 2 pi r. Just getting back to the circumference of a circle, and I will do the area when r is 2, and I'll probably do it this way. I'll ask him to draw the circle with a radius of 2, and then I'll say, well, what is 2 times 2? 2 times 2, I guess I got to go all the way up, right? 2 times 2 is 4 units. And we have another one over here. We've got another 4 units over here. And another what? 4 units over here. And another what? 4 units over here, but there's a lot of error. So how many did I do? Oh, I did 4 of them, right? 4 chunks of 4. But our circle has less area than that, right? That area. So guess what? That gets multiplied by pi 3.14. That's what I'm going to do. Give him a little estimate, and then I'm going to give him that. And I just figured that out on the fly today. Is it the best way? I don't know, but it's a picture. And pictures are worth a lot, right? And so square the radius and multiply it times pi, and you got the area of a circle. That's a start. We start the conversation. Where it will go? Hey, If we work until the end of the year, the end of the school year, where will we be talking about that? I don't know. We'll see. All right, so that's early math, lesson 14. And I'll upload the worksheet that goes with it. And so anybody teaching youngsters at home can just copy along with the early math. I think it's probably a second grade curriculum starting there. You might be first, preferably first, but most students have gaps already by that point in time. I got high school kids coming in that don't know their rules of fractions, and it's not uncommon now. So, and I get bright kids working with some really good, strong, motivated students. And yet, that's where we are as a country right now. And I'm doing these really in an effort to say we got to change the way we teach. And I think that I've seen it happen since the mid-90s. What happens when I start doing worksheets that are repetitive? The gains have been astronomical compared to what I was doing before. All right, what I was doing before, half the class might not be able to write the equation of line at the end of Algebra 2. And that was always why did that happen? I thought I covered that well. And then I just said, well, we'll do it every day. And that's when I started learning math myself. All right, rambling.